And now, John, would you like to introduce Tim?
Yeah, so hi everyone. Thanks for joining us. Again, my name is John. I am our new COO here at Santa Cruz Works. And one of the things that we've been really focused on this summer is building out an AI platform to support startups here in Santa Cruz by giving them tools and infrastructure to use and build on top of AI. And so we're really excited today to really welcome our first guest and speaker in this AI series, Tim Grashevsky. Tim is head of startups at Confluent, and you get to hear from Tim how much DNA, how much Santa Cruz DNA is actually in this company, both from the founder team, but also from a technology perspective. And so Tim's going to tell you all about what they're doing over there to support real-time data streams, which is critical to many of the companies that in past cohorts at Santa Cruz. And we suspect that there will be a lot that his tool will be useful in building future companies here in Santa Cruz. So yeah, so without further ado, please give me a warm welcome to Tim.
Thank you very much, John. It's great to be here and to meet the folks at Santa Cruz Works. Um, so here's what I'm going to do today. We're going to talk. This is designed as really an introduction to Apache Kafka and data streaming more broadly for early stage startups. So my goal with this, um, as you walk away from this webinar, you'll have a better sense of really what data streaming is, the various use cases in which it is most commonly deployed, and the various resources available to you as an early stage startup to get moving in that project. As you'll see, this is a fairly broad scope and complicated sort of topic area. So there's no way I can cover everything in one presentation. I assure you, you can go as deep as you want based on a variety of our developer relations toolkits and webinars and certifications, which the startup which the Santa Cruz Works team will make available to you if that works. There's really three things I want to talk about. First of all is Confluent for Startups, and that's the program that I run, and what's available to you as a startup from our Confluent for Startups program, as well as our AI Accelerator. Second, I'm going to give a very basic introduction to what is Kafka, what is data streaming, what is sort of the nomenclature around this topic, just to kind of give you a better sense of how it's different from the way data analytics and data management has traditionally been done, and how it powers, in the next topic, some core use cases that may be relevant and applicable to the startup that you're building. I can assure you that everyone on this call today has engaged with Kafka and possibly with Confluent in your everyday life. You just probably didn't know it. It's one of those things where it's embedded in a lot of the experiences that you have on your mobile phone while you're watching television, as you're booking a flight, or whatever the case might be. And so today you'll walk away and go, so I guess I kind of understand how that works now. And of course, there'll be time at the end for question and answer. Before we go into the meat of the thing, just a real quick bio about myself. My background is a little bit unusual in the sense that it is split almost evenly between big tech and startups. So I spent about 15 years at Oracle and Intuit, almost evenly split, doing strategic alliances and corporate development, which is another way of saying sort of mergers and acquisitions. So I was on one side of the table buying software companies for Oracle and then for Intuit. And then in 2014, I branched out to become an entrepreneur myself, and I did it twice with the same founder. Our first company was called Nav. It's still around, nav.com. By the way, it's for small business credit and financing. So if you are a small business and you're looking to get access to business credit cards, small business loans, etc., that's what that business does. Last year, we did about 75 million in ARR. There's about 200 employees around the country. And we raised over $100 million in venture capital to support that business over the past 10 years. So that was a really fun experience. In 2018, I left and founded a company called Cake, which was an internet mobile web browser. It was much smaller. We probably got to a couple million in revenue, a little over 10 employees, raised 13 million in venture capital. But in 2022, running on a runway, weren't able to get the traction we wanted, and I shut that business down. And I joined Confluent in 2023 as head of startups, which I've been doing for the past 2.5 years, where I'm trying to uh, bring my experience in both corporate tech as well as startup tech into this role. And it's been an absolute pleasure working with early stage startups all around the world. So let's talk a little bit about Confluent for Startups. This is our flagship program. Really, what you get here is free Confluent Cloud credits up to $20,000 in 1 year, but also, perhaps even more importantly, access to SEs and technical support in both Kafka and Flink. We'll talk a little bit more about that as the presentation goes on. But the thing that I would really point out here is there is Confluent for Startups. And if you're a startup now, there are these programs. Most enterprise software companies have some sort of startup program. So if you need relation or vector database from MongoDB, or a data lake from Databricks, or a data warehouse from Snowflake, or search from Elastic, I mean, the list goes on. Every one of those companies has a for startups company, right? A Databricks for startups, a Datadog for startup, for observability, whatever it might be. So that's one thing I want you all to take away is, as you start to build out your architecture and infrastructure, you should always be thinking, like, what are the benefits out there that might be available to me as a startup? Because more often than not, there is. So the other program I run is the AI Accelerator. You can see it sort of behind me here with the background. We launched this just a couple of quarters ago. And here, unlike Confluent for Startups, which is mostly about credits and some technical help, this is completely focused on AI, real-time AI use cases using generative and agentic AI. And the real benefit here is you get really deep technical mentorship and support from the best people that we have at Confluent, our PhDs in this space. And what we're looking for is really thoughtful and forward-leaning use cases that depend on real-time data streams to power the AI application. We only accept about 12 per cohort. We do cohorts twice a year. It's a 10-week program. But this is, a real accelerant for a startup if you have a very specific real-time use case. This is an example of our first cohort. It's just a minute, but I'll show you as our little hype video that also I think it shows 4 of the companies we worked with, just to kind of give you a sense of who they are and what they've done. I got to figure out how to get beyond this. There. Okay. So real quick recap. On the left, Confluent for Startups. This is a program that's open essentially to everyone. We do approve about 50% of the people that come in, but we just need to make sure that you are a software company that's not a consulting firm or working for someone else. If you're building a solution or application on top of Confluent Cloud for real-time data streaming, I can definitely approve you and get you some credits, get you some help. And it's a 12-month program, so those credits are good for a year, and that should give you a real runway to building your application. On the right, Confluent for Startups AI Accelerator, much smaller, only 12 per cohort, 10 weeks long, a lot of technical mentorship, and a lot of product support. If you want any more information on this, you can go to our website, confluent.io/startups. Both programs you can find out there. And then, of course, the Santa Cruz Works will give you my direct contact information if anybody wants to reach out to me directly. We'd be happy to talk to you. So that's topic number one. Now, topic number two, intro to Apache Kafka and data streaming. So let's start with this. This is the founding team that created Apache Kafka about, I guess, 15 years ago now. So the man on the left, that's Jay Krebs. He received his bachelor's and his master's degree in computer science from UC Santa Cruz. So that is the Santa Cruz connection here between Confluent and Santa Cruz Works. His co-founders were his co-workers at LinkedIn, Neha and June. So I think that was Jay's first job out of Santa Cruz, was working for LinkedIn. And one of their projects was they needed real-time information for some connection of, you guys all know how LinkedIn works, various connections that would happen in real time and basically an event-driven system. So they were tasked with coming up with a way to power things on the LinkedIn platform in a real-time manner. What they created internally was ultimately dubbed Kafka. LinkedIn is owned by Microsoft. Microsoft donated that open source code to something called the Apache Network, which manages open source software, and that created something known as Apache Kafka. So Apache Kafka, as you can see here, is a distributed, really high volume, low latency, real-time data pipeline that was created from those three at LinkedIn. And then it then becomes a community source where folks from all around the world continue to add to the software project and build it up over time as like a consumer or community built software code. So for those of you, I think the original one was Linux, which most people know about and understand, but even MongoDB and Elastic and Databricks and a bunch of companies are ultimately what are known as managed services over an open source software. So if what is Kafka is what we just showed you, so what's Confluent? Well, if Kafka is an open source software code, Confluent is a managed service for data streaming. So just like there was Linux, and there was a company called Red Hat, and Red Hat allowed you to kind of more efficiently manage your Linux installations. Databricks, very popular data lake program for unstructured text for AI applications, is essentially built on Apache Spark, and so on and so forth. There's a bunch of different examples like this. So with Confluent, it isn't just Kafka, although that's sort of the base of what Confluent is. It's also stream processing with Flink. It provides governance and schema registry and connection to a whole bunch of different other data platforms. So just so you understand, Kafka and Confluent, very closely related, but different. Kafka is the open source code line. Confluent is the managed service platform provider, which is the public company, that I work for. Okay, so actually I'll go back. So what is Kafka? What is data streaming? And how is it different than how things, used to be done? So you can think of Kafka as a universal foundation for data systems. Now, whether you care about data pipelines and analytics, or writing your applications, or maybe you have microservices you're trying to connect, essentially at the end of the day, you're just trying to get data from some legacy system to where you are, right? And so Kafka is going to be a foundational part of that world of moving data in real time. So if you're like me, when you think about data, because you saw my resume, I've been doing this for 25 years, you tend to think in terms of tables, right? So tables are very good at storing representation of things in the world that our software often deals with. So like an item in your inventory, internet connected smart cars, users who have signed up on your site to get the Santa Cruz Works newsletter, all different kinds of things. You're going to see that Kafka encourages you not to think of things, but rather as events. And things that happen in the world at a specific point in time, you can think of as an event. So, like an item is getting sold at that moment is an event. A driver in a connected smart car using their turn signal or a user clicking somewhere on your site, those are all events. And events form the backbone of contemporary data systems. And Kafka is the infrastructure that the world increasingly is using to manage that worldview of data. And because an event is by its very nature a thing that happens at a particular point in time, Kafka is focused on processing events in real time. So this means that the systems built on Kafka tend to do their computation on events as soon as they occur. They don't store them in tables or files or some other structure to be processed somewhere later down the road. You never put data, in other words, over here that you're going to get back to later. As an event happens, you do the work immediately. And so let me give you a couple of real world examples that you've probably engaged with. The most simple one I can think of, and this is the most, low lift technical one. You probably have all been on Netflix or HBO Max or whatever, and you go in and you start typing in the name of a show you want to watch, and you type in S and T and R, whatever it is for Stranger Things. And then as you're typing, the recommendations below you are automatically changing, right? So with each letter that you put into that screen is an event. And the event is further connected with your watching pattern. So it knows about you. And the fact that you've watched these other things before, if you type in S, is it going to show Stranger Things or is it going to show, I don't know, something else that begins with S that's not like Stranger Things? And it's doing that in real time. You do S, you do T, and as the system gets more information as each event occurs, it updates in real time, instantaneously, a different output. Okay. So that is the core of it, right? So you don't have to type in the full thing and then hit return and then it runs the process. That would be a batch system. This is a real-time system that delivers those results as it happens. Another great example, a little more sophisticated, but it's the same concept, is with real-time fraud detection, like with your credit card. If you're ever out and you get a text message and Capital One shoots you and says, "Did you make this purchase in Atlantic City, New Jersey for $375?" And the purchase happened, seconds ago. Well, the way it used to be, and I'm old enough to remember, you used to get an email like on Monday, and your credit card would come to you and they say, "Hey, this purchase looks really suspicious. Did you make this purchase at this date?" And it was like 4 days ago. And what happened there in the old days is they were sucking up all of this data. They were putting it in columns and tables. They were aggregating it. And they were running analysis on the full batch of information. That batch was then spitting out potentially fraudulent behavior, and they were sending emails, right? In a Kafka world, in an event-driven world, that happens instantaneously. Something happens in Atlantic City, which is not where you've been. They probably know that the last time the card on file was used was in a place that it was clearly too far away to be the same. So it all happens instantly based on events, and you get that text message literally, in seconds. That is the promise of Apache Kafka, and that's how it's delivered today by some of our biggest customers. So what I wanted to do is run through, if you will, some nomenclature about how to think about things differently using Kafka. And on the right here, I wanted to talk about too, like to the extent that this is applicable or compared to the old world of batch processing. So first is the concept of an event, right? You see a timestamp there. It happens in a specific time. It's not a batch record that's collected over time and processed later on. The other big concept is one of a topic. So a topic is like a named data stream. It's what you kind of put a bunch of information in, and it's a persistent stream of arriving events that you can read from any point in time. This is also different from batch, where a batch is a static snapshot of things that have happened at either when they've all been aggregated or connected, as opposed to that topic that you can look at over time through a period. So you see here in the example, a topic could be like payments received constantly over time, whereas a batch is only going to be able to give you some sort of time-bound view of things. Next is the concept of partition. So partition is a physical kind of piece of a topic, right? So Kafka scales by splitting up these topics into partitions, because the topics, again, is this long stream. And then events within the partition are very particularly ordered. So by building in this parallel, and for order streaming, for instance, it enables really high throughput distribution and processing. Whereas in the batch world, things often tend to be much more manual. You have to split up the file into various chunks. And so what Kafka enables you to do is to ensure that you kind of have that consistent order of processing that you're not going to get through a batch world. Now, there's also talking about, brokers and also producers and consumers. So a broker in Kafka is the server that stores all of this data. It's typically in a cluster format, compared to batch, which are sort of in job nodes. So they run periodic jobs that spin up and shut down after processing that particular batch, whereas brokers are always on. They're stream aware of servers, and they're managing these topics as they come in real time. Replication, this is basically how Kafka gets around the topic of what happens to that data, right? So in order to have, fault tolerance, one of the big thing about batch data is you take all this data, you often make multiple copies of it. It's pretty static and you have redundancy. It's also incredibly expensive because you have kind of all this data. Replication is how Kafka enables you to maintain backward-looking data, even though you're acting on it in particular real time. And now we're going to talk about producers and consumers. A producer is any client that is sending those events to the Kafka topics. Again, the Kafka topics is kind of the bucket, right, of the stream that you're putting things in. And there could be all different kinds of producers that are connecting into your Kafka pipelines, right? So your producers could be coming from an Oracle database or MongoDB, SAP ERP systems. It could be the information that's flowing from your website. Whatever the case might be, this is streaming these logs real time into Kafka as the producer of the data that fills up your pipeline. And then you have your consumers. So the consumer is the client that's going to read the events coming from those topics. They do tend to be grouped in parallel, and they are the core backbone of the ingestion of the information that is being put into the Kafka base. So a good example here, we talked about fraud detection. The fraud detection service reacts instantly to that transaction in Kafka. So in this case, the fraud detection is the consumer of the data, where in the old world, it would take, overnight or several days to make sense of it. And then last but not least is the concept of a schema registry. Schema registry is a way for you to think about governance or data governance. So the data that's coming in is all treated the same. So you can see here the various forms in which it might come in. And really what it does is it forces sort of consistent data formats across your pipelines so that you're able to run those analytics in a higher confidence manner between the producers and consumers, because you're treating the information, or you're considering the data with consistent definitions, is the way to think about it. So I realize that this is a ton of information to just throw at you, but these are sort of the building blocks of the Kafka backbone system of data infrastructure, and how you may think of it differently from batch processing, for whether it's events, topics, streams, producers, consumers, and registry. So now all of this stuff that I've just blazed through, we have a further online course you can take that's like an hour long that dives into each of these things and actually gives you very real world examples of how they work, and how you can do it on your own, or getting spun up on a Confluent Cloud instance and building a pipeline yourself. And again, that's free to watch, and it probably does assume that you've got some computer science background to begin with. but we can make that available to anyone who's interested. So now let's talk a little bit about, you've heard about Confluent for Startups, that you have access to this. You've heard basically the thematic perspective of data streaming and what it empowers for startups. So let's talk about 5 use cases that may be germane for you, and how you may deploy a data streaming service to help you. Now, these are just 5. We have a website of use cases that's literally scores deep. These are 5 that I just particularly picked because they're either large or very specific to startups, but I thought these would be ones that would be of most germane to the people on this call. So first one, let's say out of the bat, is artificial intelligence. I probably don't need to belabor the point about why that is of particular interest. But here's the way to think about it. If you call it 1.0 of AI, in which large language models were spun up on static data, on a static corpus of data, we are moving to a 2.0 kind of world in which AI is going to be increasingly generated and developed and expanded off of real-time data flows, right? So as opposed to just going in and, like OpenAI and stuff have made some real progress on this. But if you remember, like when OpenAI 2 or something like, or ChatGPT 2, if you typed in something and if it was before November or whatever, it would tell you, like, I don't know anything that happened after that, right? So what data streaming is allowing you to do is to bring in real-time data streams that are then leveraged by AI models for very powerful downstream applications for users. So here's just sort of a depiction here of how you might use real-time streams for AI for bookings of a flight, about how you kind of come in, you make uh, the bookings on the flight and how it interacts. And by the way, these things are generally called a reference architecture, about how data flows back and forth between the various systems, including in this case, the model looking for fraud, which is the TensorFlow from Google. And this just kind of shows you how the data flows from the data streaming components to the AI pieces to the other components of a software application, whether it's a mobile app or business analytics or reporting, or what have you. So the takeaway here is if you were working on an AI application and real-time data up to speed is really important to you, Kafka and Confluent is a great solution. One of the companies in our most recent AI accelerator, the one that happened earlier this year, good example. The guy used to work at Uber, which is a big Confluent shop. As you are looking on your Uber and you see all those cars moving around and they're getting closer to you, that's all Confluent that's powering that real-time data. And he did real-time dynamic pricing, and he created a dynamic pricing algorithm that when you show up on the website for e-commerce, based on your browser history and everything, it kind of knows exactly who you are, and it gives you special deals based on what the engine thinks is the exact right price to get you to buy, right? But that's an example of something that needs to happen like instantaneously in real time as you land on the site, and it's powered by Confluent. Second is this concept of data products, and these are for startups, maybe like some of you, that are selling insights and intelligence or analytics. If there's anything like that in which real time becomes very important for you, where you're powering dashboards, various metrics, user information, this again too is a depiction of data flows powered by Confluent in real time. And again, so if you have a product that is really focused on real-time data with insights that are going to depend on information that's flowing through your stream processing, another great potential use case. Third, and this is more of a macro issue, and I would say for startups, if you're really just getting started, you may want to think about developing an event-driven architecture around microservices because of the speed and flexibility that it enables. So essentially, what this part means is in the old days, people would build a giant um, software product, and sometimes this is referred to as a monolith, where essentially changing everything is almost hard coded together, and changing anything from one piece to another requires you to go in and kind of get under the hood of the entire application. Whereas first of all, microservices and event-driven microservices allows you to kind of plug and play various different components of your software stack as you build up. So if things are not working, you can kind of swap things in and out. If you need to take a certain component of your application offline, you can just sort of uh, handle it in isolation. And essentially, there's a ton of efficiencies and effectiveness that become available when you start thinking about being event driven and a microservices company. So it's faster. It does have more of site reliability. It does make adding new features far, far faster. Um, and I think it's also just makes your company uh, almost future proof, right? Like you can scale confidently in the event that your product takes off and you go from having hundreds to thousands to millions of users or something like that. It'll give you that capability. Number four is observability. This is, I just brought this out because I think, well, first of all, we're seeing a lot of it with the startups that are coming to us who are building observability platforms. What observability means is essentially the real-time monitoring and hopefully sort of automated shifting and control of sophisticated IT systems in real time to ensure load balancing, to ensure scalability, to ensure fault tolerance. As your application becomes more and more robust, it becomes more sophisticated, you need to be really smart about how all of this is balancing out. So number one, you don't get stuck with this huge AWS bill one month for $200,000 that you weren't anticipating because these things got out of whack. Um, as well as the fact that you can do root cause analysis when you have these issues. You can have a dashboard that's letting you know how your overall platform is performing. And the major company here that's done this for years is called Datadog, but there's been a number of others in the startup space who have been focused on this. We had two of them in our last AI accelerator. I met with a couple of them earlier this week. And so observability is one that may be a focus area for your company, or it might be something that you want to think about using yourself to ensure the efficient resource allocation for your startup. And last but not least is the concept of Internet of Things. I'm sure you guys are generally familiar with this, but it's essentially allowing for a pipeline ingestion of sensor data from a variety of different sources. So it might be wearables like your watch or other things like that. It could be RFID devices, other controls and sensors. And what Confluent allows you to do is obviously high throughput, low latency for these devices. So one of the startups in our AI accelerator last cohort was a company that did digital twins. And what a digital twin is as it might imply, is it gives you like a real-time view of some sort of process or physical location as it is occurring in real time. So one of the proofs of concepts we're working on with them is with the Wynn in Las Vegas, where the Wynn has all these CCTVs. They've got all of the point of sale software that's in their bars and the restaurants and all these other things. And what you're able to do is kind of put like an AI wrapper around uh, the CCTV, which can then tell you roughly how many people are in, let's just say, a given bar at any one time. It knows how many bartenders are working there. It can track the amount of money that's being, registered at the till at any given time. And it's essentially just sucking in what is known as the vernacular of telemetry, which could be, like I said, anything from video data to audio data, to software POC data, inventory, so on and so forth. And doing it like I said, in real time, high volume, low latency. And then you get to, put a layer on top of that of insight. So in the case of the win, do we need to put another bartender or another, waiter or waitress in this area? Do we need to restock this bar with this kind of drink or whatever the case might be? And that's a great example of where you can only do that if you have real-time data pipelines feeding that digital twin. So that, in summary, is a brief whirlwind through Confluent for Startups, an introduction to Kafka and data streaming, and a few use cases that I thought might be particularly relevant for this crowd. So with that, we still have plenty of time I wanted to keep here for Q&A. And so with that, I will stop my share and hand it over to Doug.
Yeah, that was fascinating, Tim. I don't know if you know my background, but it was in open source, and so I've been following it almost since the inception. You answered a lot of the questions that I had initially about, like how will AI native companies evolve their data structures to be real-time LM type of workloads. But I'm just curious, how does your commercialization, how does your monetization of the company compare to, say, like Red Hat? Is it very similar in terms of support being the paid, when people want support from the software publisher, that's how you get it?
Yeah, exactly. So, well, first of all, one of the primary use cases we have within Confluent for Startups is startups who want to transition away from open source Kafka um, for a variety of reasons. So if you're an early stage company, the great thing about open source, and if you're familiar with this, I'm sure you've worked with it, it's free in theory, right? It's free software. You get to do a lot of stuff with it, but then you have to maintain it. And then you have to have resources who are maintaining that Kafka implementation, right? And so what happens in our case is we get a lot of startups who started building out data pipelines using Kafka. They started to scale, and now they realize they got like 2 or 3 engineers whose like full-time job is just maintaining this data pipeline, right? And they realize that that's not the core value of their product. Whatever they're doing a digital twin or they're doing, an AI agent or something like that. They want their resources focused on the core product, and they move to Confluent as a managed service because then we provide the support. We do a lot in terms of hosting. It's on Confluent Cloud. You just kind of pay what we call pay as you go. So it's kind of like a utility. You go in there and you're paying for the amount of data that's flowing through your pipe, right? So the more data that you're flowing through, the more that you're using the product, the more you pay at a discount too, as you might imagine, right? I mean, let's just say, Capital One on a relative basis is paying a lot less for the data that's flowing through than an early stage startup because they're throwing through petabytes of data. Yeah, and that's essentially kind of how it works. Number one, you can do what you call pay as you go, or we have another option called with a commit deal. And then if you say, well, you know what, we're willing to commit to $50,000 over the next 2 years, and then you kind of get an additional discount because you're committing in contract that you're going to spend that much. And then basically, as you start to consume, you just consume the amount that you pre-bought. And we just charge you like on a monthly basis. So this way your costs are a bit more known and they're not lumpy going up and down. So a lot of companies just like the predictability of that cost.
That's great. Sorry, I am going to, I saw that one person wanted to possibly ask you some questions, and somehow he had become panelist. He's now an
I can
attendee, James
I can
O'Connor. So I think James wanted to ask a question. And how do we get this? We have to unmute him. Oh, shoot. Let's see.
I can read the question too, Tim, if that's all right.
Sure.
Tim, the question is there a package size limitation on the data stream? How do you compare to other streaming platforms like PubNub?
And James, you are unmuted too now.
Okay, good. It kicked me out and let me back in, and I don't have the controls over the video anymore.
Yeah, because I don't know. I'll tell you later. Anyway,
So I think the question was on pricing. I think it's pub sub, I think would be what you're asking.
PubNub.
Pub nub, yeah. Well, so uh, here's my kind of general thoughts on Confluent. At one point, when I joined the company, I think we really had a reputation as being really premium priced. And that's because we were sort of the innovator in the space, the pioneer in the space. And consequently, and this is kind of what happens when you're a company, is then you start having a bunch of other companies that try to compete with you on price, with sort of a, call it a reduced or dumbed down product, but at a fraction of the cost. And a couple of those companies got a bunch of venture backing, at which point, and the good thing I think for consumers is, that really caused us to react. And we've dramatically taken down our pricing in the past like 18 months. So we now have, I mean, our head of product will say that like we will never lose on price. So even if you're talking AWS's feature, which is called MSK, Managed Service for Kafka, or Red Panda, which takes a very different approach to Kafka, but it's still data streaming. Um, Avon, which is another company out of Finland. So our view is that we will match or beat any pricing from those competitors. I do think that there are probably some other workarounds, like with BigQuery and PubSub and stuff like that, where you're not doing exactly Kafka data streaming, but you're accomplishing a similar task in a different way. On that, I can't fully speak to. My guess would be, because I deal with a lot of startups, obviously, who claim to have real time as part of their solution set. But then it depends on what do you mean by real time, right? Is real time sub, tenths of a second, or is real time in seconds? And depending on your use case, it may not matter, or it may matter a lot. Do you know what I'm saying? So in some cases, with some of the companies that we deal with, it has to be extremely low latency in order for them to get the value of what they're trying to do. Traders and things like that. Gaming companies, another good one in terms of like the speed that they need to handle. But there's others that I would call it kind of pseudo real time, which is, fast, but not particularly super low latency from the world of data streaming. And there may be other ways in which you can do that more cheaply, but
does
I
that,
don't have those.
James, does that answer your question?
Yeah, I mean, so just to give you some context, Tim, I have a SaaS platform and we use PubNub right now, which is a real-time message notification system. We use it for in-app chat and also just to broadcast updates when things change in the back end so the front end stays in sync with it. And it
Yep.
doesn't sound like Kafka is the right use case for that. It's more like I'm logging stuff in the back end and I want to broadcast those changes to other services in the platform. Is that the
Yeah.
way I should think about it?
Sort of, although I mean, a very common use case of Kafka is message queuing and logging. So it sounds like that's maybe kind of what you're doing. So if you want, I can send you some other, and that's also a very basic use case, right? We get a lot of people coming in who are doing message queuing and log ingestion. So if that's what you're doing, that may be applicable. And then depending too on like on the requirements of your use case, uh, it kind of will figure out whether it makes sense or not.
Yeah. Okay. Yeah, I was actually talking to AI about you while you were doing this and comparing it to PubNub for what I do. And it seems like from my gestalt, this really makes sense as you scale up
Mhm.
and things get really, really big and you have lots of, hundreds of thousands of users. That seems like where it really starts to matter because you're not as fast as PubNub for real-time in-app chat and stuff like that, which
Mhm.
kind of makes sense. That's their like sweet spot. But like, for example, for doing all of my analytics inside the platform and tracking all that stuff and logging that, and that seems like you'd be a great tool for that. Right now, our analytics are a problem because we're storing them in our database, and I'd love
Uh-huh.
to store them elsewhere and be able to generate those metrics without loading up my database.
Yeah, yeah. Yeah, so as it's actually funny when you said pub nub because we often we do run into pub sub, right?
Right.
It's published quite a bit. So that's why I thought that's what you meant.
Now, PubNub is an actual company. We've actually used them for years and years and years. They make a like essentially a real-time event notification system. So it's great for chat and presence notification. And
Yeah,
when things change in the app, like some new data shows up, it can send a message to the front end, and then it goes, okay, call the API and get the latest version of it. It seems like your infrastructure is really more about streaming data on the back end, not really so much between your front end app and your back end app, more for the orchestration of event management in the back end.
that's right. That's right.
Okay, cool.
This
And
is
how would I know to like how I use AWS for everything? Why would I choose you over AWS's Kafka?
Yeah, so well, two reasons. Uh, First and foremost, AWS only works on AWS, right?
Mhm.
And so we've seen a lot of companies move to a hybrid model where they're on GCP and AWS or plus Azure or whatever, right? So if that's what you were doing, and they do that for redundancy and fault tolerance and a variety of other reasons. So if that's important to you, you cannot use MSK for that, number one.
Okay.
Number two, it is, and I think, and by the way, AWS is our number one partner. We are the number, here's a statistic for you. We are the third largest source of data into S3 globally. So think about that. So the third largest source of data flowing into S3 buckets globally for AWS is coming from Confluent. So we are a very close partner of theirs, and I meet with them every 2 weeks. And MSK is often used for fairly lightweight data streaming pipeline applications. So in terms of latency and scale, we've had a bunch of companies that have come to us from MSK when it can no longer manage what they need to do. We've had some people, go from us to MSK to save some money and then come back in 6 months because it couldn't scale up. And I think the AWS people would be the first to say that. And by the way, I wouldn't say that, MSK is never right. I think there might be some use cases where if you're only on AWS and you have a very simple use case, dollar for dollar, it may be the better approach for you. If you have a more sophisticated use case, you'll probably want to use Confluent.
Okay.
Mhm.
All right. So it sounds to me like it's almost like I would just start with MSK, get my feet wet, and then move to Kafka eventually, or because it's cheaper, or you know what I'm saying?
Yeah, well, first of all, you would be starting with MSK. Now, I mean, Kafka, the K in MSK is Kafka, right? Which
Right.
is the open source piece. It's the managed service piece. So you start with MSK, and I think if that, like you said, you're on AWS and maybe your use case is pretty straightforward, yeah, I would encourage you to actually do that and see how that goes. And then if you're running into limitations, you know that there is an easy way to transition while staying on AWS, transition to a different Kafka managed service provider that will give you more functionality, more features, and allow you, should you decide to move to different cloud environments.
Okay.
And
Makes
we're
perfect.
joined by the Innovation Business Engagement Hub at UC Santa Cruz and our local co-working office, Next Space. Question from them. Are you seeing a significant uptick in data streams due to like agentic AI? And if someone is either using agentic AI or building a tool on top of it, is that something that is a good fit for Confluent?
Yeah, for sure. Like I mentioned before, our AI accelerator, which by the way, cohort 2 kicks off on September 8th. We looked specifically for generative and increasingly agentic AI solutions. When I showed the video earlier, one of the first company was called Agent Taskflow, which is a multi AI agent orchestration platform. And we actually wrote a technical profile with them. As a matter of fact, if you want, I'll just drop that in the chat here if that works for you guys.
Yeah,
And this is so this will in some detail give you guys uh,
great.
some details about how Confluent is used in a multi-agent environment, AI agent environment, including reference diagrams, schematics, and so on. So yeah, take a look at that. And I mean, make no mistake, right? I mean, we are all in on AI. We think that these models are going to be increasingly dependent on real-time data. And our hope, is that data streaming is going to be, the next GPU, right? Where it's like if you want to do AI for real, um, and you're going to need Confluent's platform because only Confluent, just like only NVIDIA, can handle the parallel processing power required to train these things. Only Confluent has pipes that are wide enough, fast enough, to do what needs to be done with agentic AI and generative. So that's the hope, right? That's what we're trying to do.
Start early and build on top of Confluent is what I'm hearing.
Yeah, and that's the other thing too with the Confluent for Startups program is there's a lot of stuff that you should, frankly, you should just let us handle it because it's going to save you so much time and money. So if you go to our website, confluence.io/startups, there's a video on our homepage where a few of our startups talk. And essentially that's what they say, right? Is like they had a vision of what they wanted to do, whether it was a digital twin company or AI agents, or one of the companies featured is a company that is a vertical SaaS solution for charter busing. And they were just like, let Confluent do all of like the heavy lifting in the back end, and we're going to spend our time focusing on the end user layer and application to make that a great user experience and delight the customer, and just let Confluent do all like the plumbing and the engine behind it. Uh, and that should save you time and ultimately will save you money because there's a lot of stuff. These people will say it could have taken us a year to build out what we wanted to build, but we just took what you had out of the package and then just built on top of it.
Well, Tim, this has been extremely informative, and I got to congratulate you on. I've been to a lot of technical seminars throughout my career, and the way you just set it all up made it so easy to understand. I really appreciate that. So for our attendees, again, we thank Tim for everything he's done here today, and we will be uh, um, taking this recording and placing it on our website and in our newsletters, as well as a brief. So with that, we're going to wrap up here, and remind you that we have great partners out there and sponsors that have helped us. And we are looking forward to having you join us in our next events.